Good evening, everybody, and welcome to another semester at Sea Wavelengths. We are coming to you from both the Chicago area and Knoxville, Tennessee. We wanted to welcome the extended family of Semester at Sea, the community of Semester at Sea, and we're very excited to be here with you. If you've joined before, you know that the Wavelengths series started in April as a way to cultivate joy and strengthen our community during these uncertain times, and also to share the many talents of our alumni around the globe. Each week we will be featuring a new Semester at Sea alum from a different industry or career field on Wednesdays from 4 to 6 p.m. Mountain Time here on the official Semester at Sea Facebook page. I'm Shelley Galloway. I've served as president of the Alumni Council. I've been on the Parents Council. I'm now on the Lifelong Learner Council. My 3 children sailed in spring 04, 05, and 08. And I am representing the spring 10 voyage 10. We're celebrating our 10th anniversary of our sailing. I've sailed with my husband and extended family. So I have a lot of strong feeling for the Semester at Sea community. This evening, I have the distinct pleasure of speaking with Dr. Lee Riedinger, who sailed with me on the spring 10 voyage with his wife, Tina, and she was also a professor on the voyage. Dr. Riedinger is an emeritus professor of physics at the University of Tennessee in Knoxville. And when he was on the ship, he taught courses in energy, technology, and the nuclear age. And his wife, Tina, taught astronomy and led us in some wonderful stargazing experiences. Lee has been on the faculty at UT since 1971. He retired in 2019 and also served as the founding director of the Bredesen Center of Interdisciplinary Research and Graduate Education from 2010 to 2019. He received a PhD from Vanderbilt University in 1968. His field of research is experimental nuclear physics, emphasizing the properties of high spin states in the deformed nuclei, which sends me into a high speed state just saying it. He is an author of 200 refereed publications and has given 60 invited talks at conferences and workshops. And he says he's going to be doing several Zoom lectures this fall. He is also a fellow of the American Physical Society and of the American Association for the Advancement of Science. His research was funded by the Department of Energy for 30 years. And Lee has led various efforts to develop a greater focus on energy teaching and research at UT. He retired from the university in 2019 after 49 years. Congratulations. And he is writing a book on the history of the partnership between UT and Oak Ridge beginning in the Manhattan Project. And may I also add that from my own personal knowledge, Lee is an expert snow skier, water skier, and he could teach all of us to do Western line dancing if we were lucky enough to be there with him and learn the steps. So Lee, I'd just like to welcome you first of all, and ask you if you could share a little bit about how you became a faculty member on Semester at Sea.
Shelley, it's great to see you. Getting to know you on the spring voyage 2010 was a highlight of my life. And one way I got involved was that Lauren Crabtree was my boss for a while at the University of Tennessee. Right. He was our chancellor. Mm-hmm. I served for a while as his vice chancellor for research. And then he and the president of the university had a parting of the ways, and Lauren decided to go and be a vice president at Semester at Sea up in Charlottesville, Virginia. Right. About a year after that, he called me one day and said that he had decided he would be executive dean one last time on the voyage in spring of 2010, and said that that Tina and I should go as two of his 35 faculty. Well, I said, Lauren, I don't know. I've got graduate students and courses to teach and responsibilities. I have to think about that. I went home and told Tina, and she says, I'm going.
Yeah, exactly. Yeah.
And therefore I needed to go too. And so
Right.
all my responsibilities did not matter. And so it was Lauren Crabtree, now Emeritus President of Semester at Sea, that got us onto that wonderful voyage.
Yeah, it was a great team, great dean team we had on that voyage.
It
Mark
was.
White and Lauren were fantastic together. So what are a few of your favorite stories about your semester at sea experience?
Well, before we left, we looked at the itinerary, and I would have guessed we both felt that going to Vietnam was probably low on our list because at our age, we lived through the Vietnam War.
Right.
Luckily, I avoided that of being drafted, but still it was traumatic. And so we did not relish going to Ho Chi Minh City. But when we got there, it was wonderful. And we had a great time. But we were on top of at the rooftop bar of the, what was that hotel?
I know I'm gonna forget too.
The special hotel in Saigon / Ho Chi Minh City. And we were having a beer up there. And a young couple at the next table were having a drink and trying to photograph each other. So I went over and said, can I take your photograph with your cell phone? And we got talking. They were clearly American. And I said, what are you doing here in Vietnam? Well, no. And I guess first they asked me, what are we doing? I said, we're faculty on semester at sea. And then I asked them. And she said, we're on our honeymoon.
Oh,
and I thought, who on their honeymoon goes to Ho Chi Minh City? And then the young lady explained that she had been on semester at sea as a student 2 years before.
Oh my gosh, wow.
And that's who goes to Ho Chi Minh City on their honeymoon because they've been exposed to the world.
Well, I was just there in fall of 18. And if you haven't been back, you would not believe the change. Mm-hmm. Unbelievable. I went to a movie there, the Freddie Mercury movie, and I felt like I was in New York City. It was amazing to sit in this theater with the concierge that brought me my popcorn, and I'm watching Queen, and I'm in Ho Chi Minh City on the ship. It was quite a mind twist, to say the least. So
we took a little trip from Vietnam to Cambodia, a semester at sea little side trip. And I was so impressed with how these countries have recovered and even prospered from those awful days in the 60s and 70s when those countries were decimated by war. And so the spirit of humans is amazing.
If I recall, we had a panel discussion on the ship, and there were faculty members who had served, faculty and staff, and they really personalized the whole experience and the emotions of traveling back there and what their life was like at the time. I think that was really helpful for the students to hear their perspective.
And one of the students told us he went out drinking beer one night off of the ship and ended up drinking beer with two elderly Vietnamese men. It turns out one was Viet Cong and one was from the South. Mm-hmm. And they all shared beer and talked about the old days.
Wow.
Not angry, just talking about history.
Yeah, pretty amazing.
Yes.
So what impact did semester at sea have on your life or your career?
Well, I've traveled a lot as a nuclear physicist, going to conferences, doing experiments around the world, but that's more of the beaten path of Europe. Right. I've been to China quite a bit, but one value of semester at sea was being able to see things in the world that I would never have seen otherwise. Right. Going to Vietnam or India or Ghana. Right. And that was really nice to see different aspects of the world and the people involved in the world. And so that changed me. Now, seeing the Taj Mahal was stunning, the most beautiful building I've ever seen, but also seeing the extreme poverty of people sleeping on the streets in New Delhi, mm-hmm. seeing the class system up close and personal. That dichotomy has never left me.
Right. And I think it's even more poignant right now when we look at the numbers of COVID cases in India right now and how it's affecting the rural population. It just hurts me to think about it. And I feel for the country. So on that note, I would like to lead you into your presentation by saying, I think our timing is pretty amazing. As we were talking before we started, with the storms, the hurricane, and of course, I think of possibly COVID being somewhat related to global warming, possibly, and also the forest fires. That might be something that you would debate, but I would welcome you to share your thoughts with us on that topic.
I would be glad to, Shelley, and thank you to everyone out there in the ether world. So I'm going to share my screen here. Should I start, Shelley?
Yes, please.
Okay. All right. Shelley, can you see my shared screen?
I can.
Okay, good. Well, I want to talk about climate change. As Shelley said, I've started a PhD program between the university and the National Laboratory in Energy. And one key part of the energy discussion is what certain types of energy do to our climate, both past and future. And so that's what I want to talk about. Let's see. Hang on a second. This is not letting me change. I'm going to back out of this for a second, Shelley, and then get back in. Okay, I'm trying that again. I'm going to share a screen now. And now I'm going to go to.
We don't care if you have to keep it in your view where you see the notes, but.
Okay, this works. Now I can change it easily. Okay. So I want to talk about climate change. Now, about the history and the present and the future. I want everybody to be aware of these websites. This website right here tells you what the CO2 content of the Earth's atmosphere is right now. And I checked yesterday, it's 412 parts per million. The US EIA, Energy Information Administration, has a wealth of information on energy use and climate. Climate Central is another good website if one wants to pursue more information, some of which I referred to here. Of course, this is the greenhouse effect. We know this well. We know the physics of this. We know that sunlight penetrates the atmosphere and heats the Earth. The Earth then gets hot and radiates in the infrared frequency range. And it is then primarily a carbon dioxide molecule in the atmosphere that absorbs the infrared radiated from the warm Earth and distributes that heat. Also, of course, water molecule does the same and methane does the same, but carbon dioxide is the best. And we're lucky that we have that. It's not a lot of CO2 in the atmosphere. It's 0.03% of our atmosphere, but that's the molecule that keeps the Earth livable. And if we didn't have it on Earth, the Earth would be 59 degrees cooler when you judge how much radiation we're getting from the sun. And so luckily we have the greenhouse effect, and that's what makes the night not so cold and overall the Earth warmer than you would expect. The problem is, of course, that the amount of CO2 in the atmosphere has been rising regularly, and it's now 47% higher in content than it was 100 years ago. And so the Earth is becoming a better greenhouse. This is not rocket science, this is clear. In fact, 2016 is the hottest year on record on Earth, and 2019 is number 2. And you can see in the last, this has all happened recently. There's the graph that 2016 was the warmest, 1.5 degrees Celsius warmer than the average over the last 100 years. 2019 almost as warm. And it's getting warmer all the time, year by year, as we go on. And in fact, the Earth is becoming warmer now than it has been in the last 12,000 years. And so that's a big worry. And of course, we know the issue, we know the reason. That's because humans have been burning so much fossil fuel, putting so much CO2 into the atmosphere. And we know that's true because since 1960, people have been doing measurements of the CO2 content of the atmosphere with instruments on top of Mauna Loa in Hawaii. And this is the CO2 content going up and up year by year. In 1960, you see it's down around 315 parts per million. In mid 1800s, it was 280 parts per million. Now we're up at 412. And so that's going to keep increasing because the Earth continues to warm because we're burning so much fossil fuel. In fact, humans put in twice as much CO2 into the atmosphere as nature can handle in a normal way because we burn a lot of fossil fuel. So a few things that everyone should realize. First of all, climate is defined to be a global long-term thing. Climate is defined to be an average of 10 to 20 years of weather effects. And so climate change is not year to year change of weather, or it's warm this season or cold next season. It's more of a long-term global change in the temperature. And the reason is the CO2 content is increasing. Water vapor is the best greenhouse gas, but on average, a water molecule stays in the atmosphere only 7 days because then it rains. And the water molecule is gone after it rains. Methane is very potent greenhouse gas also, but luckily the amount of it in the atmosphere is only 20 times less than CO2. The problem, of course, is we burn a lot of fossil fuel on Earth. Methane, coal, gasoline, petroleum, and we return every day 3,000 years of fossilized carbon dioxide back to the atmosphere. Now, the oceans help the problem. Oceans on Earth absorb about a quarter of the CO2 that we emit, but that's not enough to cure the problem. Now, the oceans are getting warmer. The oceans are getting more acidic. The oceans are rising in level because of all of these impacts. You know, we're going to lose at some point the coral reefs because of increased temperature and increased acidity of the oceans. And of course, we know the glaciers on Earth are receding and disappearing rapidly. And for example, this is two photographs, some glacier in Argentina 20 years ago in 1986, 20 years later, 2006, and you see the same time of year, the glacier has receded enormously, just up at the top. And we're seeing that all over the Earth. The glaciers are receding. So there's no debate about the fact that the climate is warming. And the average temperature in the last 100 years has increased by about 1 degree Celsius. That's 1.8 degrees Fahrenheit. That does not seem a lot, but it is a lot when you look at how glaciers are disappearing and receding on Earth. People question, people criticize how you come up with that one number, the global temperature year by year. Well, it's difficult. It takes a lot of measurement. And so there's a whole network around the globe of instruments that measure the temperature every day around the globe throughout the year. And you have to do a lot of correction of those numbers to come up with a global temperature on Earth for the whole year. That is done carefully. There is a group in the UK, East Anglia University, Goddard in the US, the National Climate Center in the US. These three organizations analyze those data, compare their conclusions, and that's where we say that it's about 1 degree Celsius warmer now than it was 100 years ago. And it's the world climate scientists organized around the IPCC, the International Panel on Climate Change, a UN, United Nations body that oversees all of this work. And so we believe it. We know the temperature is rising. Now, I want to put this in context. This is not an Earth problem really, but it's a human problem. My point is that the Earth has gone through repeated cycles of getting warmer and getting cooler, the glaciers coming down from the poles and receding. For example, here is a graph of the CO2 content of Earth going back 800,000 years in time. See, we are here in 2017, the CO2 content was 405 parts per million. 12,000 years ago, 15,000 years ago, is down to about 200 parts per million. But you see, 100,000 years ago, it went up. About every 100,000 years, the CO2 content on Earth goes up and the temperature goes up. And so that is the regular process that we know happens on Earth. The point is that we have blown through the ceiling this time, where we're, because of the burning of fossil fuel humans have done, we're well past that normal peak of the CO2 content on Earth. And so we're in an ice age now, by the way, and there are periods called glacial periods where it's cold in the ice age and the CO2 content is small. And then there's interglacials, interglacials where the CO2 content goes up and the temperature goes up. I'm not a geologist, but what I read is that we think there have been 5 major ice ages on Earth. Normally, the Earth is a lot warmer than it is now, quite a bit warmer than it is now. But for the last 2.58 million years, the Earth has been in an ice age, as evidenced by the fact that we have ice at the poles and other places throughout the year, even in summer. But some of the ice ages, like the one here, lasted for a rather long time, about 2 billion years ago. But in blue, there's 3 more recently. And so the Earth goes through this where ice ages occur regularly. But when you're not an ice age, which is most of the history of the Earth is ice-free and a lot warmer than it is now. Well, why does that happen? One cause of ice ages, we think, is the position of continents. The continents are moving around. We know that. As time goes on, they move slowly. You know, clearly Africa and South America were once together, and clearly they've been moving apart as those 2 tectonic plates move apart. So we know that. But the reason we're in an ice age now for the last 2.5 million years is that there is a continent, Antarctica, that sits at the South Pole. And there's a continent, Greenland, that blocks the pathway of the Gulf Stream to the North Pole. And, you know, they've moved around, but right now, that's why we have an ice age, because Antarctica is a high landmass and ice can build up there. And the Gulf Stream, shown here, the flow of warm water from around the equator up to the north, it gets blocked by Greenland from getting to the North Pole and the Arctic Sea. So that's why probably we're in ice age now. Well, beyond being an ice age, we can look back to over the last million years or so and find out what was the behavior of the climate, the CO2 content, the temperature. And we do that by studying ice cores drilled out of Antarctica. Vostok was the first experimental station built in Antarctica by a Russian team back in the 70s. And so Vostok sits here, not exactly at the South Pole, but it's the highest point of Antarctica. It's also the coldest point on Earth, minus 128 degrees Fahrenheit. The North Pole is a lot warmer than Vostok, because you're up at 3,000 meters, more than 3,000 meters when you're there at that place in Antarctica. And now there's many experimental stations in Antarctica from different countries. Here's the US ones precisely at the South Pole. There's Vostok. But there's a lot of experiments going on trying to study what's going on in Antarctica. Well, the Russians took the lead of drilling ice cores. And so you see at Vostok, there's a lake down 2 miles down, but above it is 2 miles of ice. And you can then drill down, take a core sample of ice down 2 miles, which means going back in time up to 400,000 years. And that's what ice drilling is. The Russians started this in 2012. You drill down, you extract a core of ice, and then you slice the ice to look at the atmosphere when that ice formed a year ago or 200,000 years ago. And you analyze that ice. That's how we look back in time to see what was the status of the atmosphere over the last 400,000 years. Well, you can deduce the CO2 content directly. When the ice forms, there's always bubbles in the ice, trapped atmosphere in the bubble as the ice formed. And that tells you what was the CO2 content of the atmosphere at the time when the bubble formed. To get the temperature, we do something that is called looking at the oxygen isotope ratio. In other words, oxygen, H2O, oxygen, the gas that we breathe in the atmosphere, has 3 isotopes. Most of it's oxygen 16, but a small percentage is oxygen 18. But now when it warms up and water evaporates from the oceans, it is more the lighter isotope that goes up as H2O evaporated. And so we know that oceans become enriched in oxygen 18 more than the 0.2% normally, and water in the atmosphere or in rain or snow is deficient in oxygen 18, and that is temperature dependent. And so the deficit of oxygen 18 gets bigger as the temperature decreases. And that's how we know from those bubbles what was the temperature when that ice formed 200,000 years ago or whatever, by looking at the oxygen isotope ratio. Well, when you extract those data from the ice cores, here's what you see. You see an oscillation in the temperature deduced from the oxygen isotope ratios. This is now, and you see you go back 120,000 years and the temperature was higher, and then 200,000 years, there's a peak about every 100,000 years in the temperature of the atmosphere. Also, when you look at the CO2 content of those bubbles, you see that it's in sync. There's a peak of CO2 at about the same time as the peak of temperature. Well, that's not rocket science either. That shows that temperature on Earth and CO2 content is related. That's the greenhouse effect. Well, so that's what we've learned, that going back in time, there is a regular oscillation throughout this ice age of temperature and CO2 content, where about every 100,000 years it gets warmer on Earth and the CO2 content goes up. And so when you look back millions of years, here's the current ice age lasting about 2.5 million years. There's these peaks where the temperature's gone up. And we're now here. If you go back 100 million years, the temperature was a lot higher. This is degrees Celsius. You know, it was 10 degrees, 8 degrees, 12 degrees Celsius higher consistently than now. So we're in an ice age, and so it's colder now. But the Earth is normally in this mode where it's a lot warmer. The oceans are a lot higher because there's no ice on Earth. The CO2 content is higher. And you notice these bumps that I just mentioned, these regular excursions in this ice age. Those are called the Milankovitch cycles. Well, you see, 12,000 years ago, or rather, the most recent cold period was about 20,000 years ago. And we know that ice came down from the poles. And here's kind of an artist's conception. Here's the North Pole. Here's Washington, D.C. on the right. Glaciers came down all the way down to about where I live, down to Kentucky, covering the Rocky Mountains, almost getting to Washington. You know, I've always wondered why Ohio is flat and Kentucky, where I grew up, is not. Well, I think that's because of this, because 20,000 years ago, about a mile or two of ice covered North America down through Ohio, roughly. And so we know that happens. And that was because it was one of those cold periods on Earth in the last 2 million years. So this is the change of temperature over the last 160,000 years. We're here, but you see the most recent cold period, 18,000 years ago, it was really quite a bit colder, 9 degrees Celsius colder. The CO2 content was lower. The ocean was 120 meters. It was 400 feet lower because there was so much water tied up in ice on the surface. That's the time of mammoths and cave people that lived near the equator because it was cold. That's when humans first walked to Australia. The oceans were so low that our ancestors walked across bridges, natural bridges, and got to Australia in this time period. The Atlantic was frozen from Greenland to Great Britain. That was the most recent cold period on Earth. And 125,000 years ago was the most recent hot period. And it was even warmer then than it is now. And there's evidence it was so warm that lions and elephants may have lived near Cornwall, England. And there may have been hippopotamuses that lived along the Thames because it was a lot warmer than now. And the sea level was 20 feet higher because there was much less ice trapped on the surface of the Earth. Well, I got to tell you about Milankovitch. He's the guy in around 1930 who figured out the possible reason for these natural oscillations in the Earth's temperature and CO2 content. He was a Serbian physicist. He got caught in World War I, spent time in a prison camp. And during that time, he worked out the rudimentary mathematics of how subtle changes in the Earth's orbit can cause an excursion of temperature. And he did these calculations, calculating the solar content, solar incidence of radiation, like at 65 degrees north latitude. And if you have a subtle change in the Earth's angle of tilt or its orbit, you then would get a slow period. You'd have less sun, you'd have shorter summer, you have more snow buildup and ice at the poles, and gradually that would lead to a glacial period where it gets very cold. And he calculated that there would be different effects with a period of 100,000 years or 41,000 years due to the Earth's subtle changes in its orbital dynamics. He published the paper not in English, in Serbian, I guess. And so the ideas were not picked up. It wasn't until 1976 that people in the US did an article in Science magazine pointing out that Milankovitch figured this out 40 years earlier. And his point is that we know about 3 subtle changes in the Earth's orbit that cause this. The Earth's orbit is elliptical, but it does change with a frequency of 100,000 years. Right now, the Earth's orbit around the sun is less elliptical than it often is. That change can cause a change in the radiation received from the sun and can trigger one of these cycles. Also, the Earth's axis is tilted by 23.5 degrees now, but that changes between 22 and 24 degrees. And that's why we have seasons. There'd be no seasons on Earth if that angle were 0, because then the Earth would be the same throughout the seasons. Or if it was a greater angle, we'd have more severe seasons. But that angle changes a little bit, which causes a change in radiation received. And the third is precession. The Earth is not fully spherical. The tides by the moon gives rise to a slight bulge, for example, water, and that causes this top to precess, just like a child's toy. It's a precessing top. And that's another subtle change in the Earth's dynamics. So when you look at all that, that's how Milankovitch explained these kind of regular excursions about every 100,000 years or so. And so 125,000 ago, it was warm on Earth. It got colder. There's bumps along the way. 18,000 years ago was the coldest period. Then the Earth started warming, a natural cycle. Of course, humans have added to this, have added a whole lot of CO2 and temperature because we've disrupted the cycle. But my point is that we should return. Most scientists think we will return to the next period of glaciation.
We do have one question on that.
Sure.
What impact might raise the bar for future catastrophe based on our CO2 production? Is it too late for us to turn the Titanic around?
Yes and no. Let me get to that in a second. I have a few comments on that. Yes, well, we cannot turn it around. We can moderate it, I hope. And so, because still the feeling is it's going to get cold again. Maybe in 20,000 years, the glaciers will come back from the poles. And last time this happened, there weren't many humans. Next time this happens, there's going to be 10 billion humans or more. And I don't know how we would handle that. The IPCC is this UN-run organization that oversees all of this. They oversee computations, trying to look to the future to answer that question of what's going to happen in the future. You use a supercomputer like the one at Oak Ridge and other places to calculate heat transfer between Earth, water, and atmosphere to see if you can predict what will happen as the CO2 content goes up. The calculations show with a wide variation that, well, by the turn of the century, if we do nothing about current input of CO2 to the atmosphere, the temperature rise could be another 4 or 5 degrees C. Wow, that's a lot. That's 8 degrees Fahrenheit. My goodness. If we back off a bit at how much CO2 we burn, maybe we can keep it to another degree beyond the 1 degree increase we've already had since the 1800s. But that's the question. Can we reduce and control the amount of CO2 emissions to avoid what I call this terrible situation where we have another 8 degrees Fahrenheit increase in temperature? And the ocean rise in these calculations could be 0.5 meter. It could be a couple feet by the turn of the century, depending upon what we do about CO2 buildup in the atmosphere. Now the oceans are rising at only 3 millimeters a year, but that will keep going and increase unless we do something. What are the long-term effects? The glaciers are receding. We know that. We know there's extreme heat events. We know that. We're losing species of animals and plants. We're going to lose the coral reefs. There is 2% of the mass of the oceans is tied up as ice on Greenland and Antarctica. As the climate warms, that's going to melt and go into oceans. That's why the oceans will rise. It seems to be a no-brainer that hurricanes We see increased number of hurricanes these days. That's because of more heat in the ocean. The purpose of a hurricane is to quickly take heat out of the ocean by a storm that dispenses the heat into the atmosphere. The oceans are getting warmer. Therefore, hurricanes are going to increase in number and intensity. That seems clear to me. Well, what can we do about that? There are strategies that people propose. None of this is ready for prime time, where we could remove CO2 from the atmosphere. We could, the second one here is sequestration by trees. We have half of the number of trees on Earth that we did a couple hundred years ago. If we could double the number of trees on Earth, that would take care of the problem. That would suck up enough CO2 that would put Mother Nature back in balance. Well, that's not likely that we're going to double the number of forests on Earth, I think. Some people say we could do chemical processes to directly capture the CO2 from the atmosphere, but that's very expensive. I don't think that's ready. That's certainly not ready for prime time. The last one, as we burn fossil fuels, we could capture the CO2 and inject it in the ground, a geologic formation like a saline aquifer, rather than letting it go in the atmosphere. That's doable. We're not doing it yet because it adds cost. So my last slide, what should we do? Well, I think first of all, we learn to live, I'm afraid, with warmer climate and more violent storms. I think society will move back from shorelines. I think we will change our agricultural patterns. It's possible in 40 years, you're not going to be growing corn in Kansas. You're going to be growing corn in Manitoba. So we're going to have to change our agricultural patterns because we're not going to stop this runaway train very quickly. And we have to be ready for more violent storms, I'm afraid. Now, what we should do, the US should do, like many countries are doing, of having a carbon tax. You see in green are countries that are already participating in different ways in experimenting with a carbon tax to make it more expensive to get energy, electricity, by burning fossil fuels. Well, if we did that, that would help a lot to reduce our dependence on fossil fuels and putting more CO2 in the atmosphere. I don't think these negative emissions technologies are going to bear fruit anytime soon. So it's mostly then reducing our energy use and using it wisely, more wisely than now. And I'm afraid moving back from shorelines until we bring this problem under control. So that's what my story is, but let's just talk about issues now. So any other questions or comments?
Do you do not think that the forest fires out west are related necessarily?
Yeah, that's hard to say.
Mm-hmm.
That's hard to say. I don't really know. There's more energy in the atmosphere. That's too, that's something that short time frame is hard to calculate. So there's a relationship, but I don't know if that's the cause, if climate change is the cause of it. Hurricanes is more clear, increased hurricanes. But forest fires, forest fires are there because we're not getting enough rain out there and because people are living too close to the forest and because the weather patterns are keeping the rain away and the heat there. So that's probably related to climate change, but I don't know the physics of that.
So do you have any advice for other alumni who are interested in a similar career path?
Well, the energy arena is very important. And we need energy, of course, on Earth. We need electricity. So we're not going to return to a day of less dependence on energy. The challenge is to find ways to use energy, generate energy more wisely. Electric vehicles, self-driving vehicles. I favor nuclear power because the CO2 footprint is very small. Clearly, wind turbines, solar panels, we need to invest more in those. The problem with those is that the wind does not always blow and the sun is not always out. And so you can't live with a variable source of electricity on your grid. But there are ways to take care of that with more robust battery strategies, for example. So yeah, I think the energy sector is a very good career.
I just saw a posting that Mekong Delta had put in a whole bunch of solar panel fields. So they're utilizing that over there, the technology over there, which, I mean, it's such a booming economy in that area that they probably need more energy sources than they've had previously.
Well, I'm impressed with how wind is happening so well in this country. I would not have predicted that. I'm very happy that wind fields of wind turbines have popped up in the Midwest, because, you know, we're lucky on most continents, you have to be at the shoreline to get intense wind patterns. But because we have a big continent, the middle of the country has a very robust and regular flux of wind. And that's why we have big wind farms in Texas and Iowa and Oklahoma and Kansas. So that's now approaching, it's over 10% of our electricity. In some places, it's 30% of our electricity. So that's good.
So do you have any advice to any faculty members who might be watching, who are looking to either return to the ship or try to find a position on the ship?
Well, I taught a course on energy issues while on the ship in 2010. That's, to me, an important topic for the ship. A friend taught a course on oceanography. That's an important topic. These are all climate related, of course. But yeah, I think my thesis has always been we need more science courses on semester at sea. And they don't have to be hardcore physics and chemistry, but they could be science related to energy or oceanography or climate that I think should be taught on semester at sea.
And also world health, I think, with all that we've experienced with the pandemic, is going to be a topic that the ship will probably touch on in all the classes. So any other final thoughts about your semester at sea experience?
Well, someone has posted a question about overpopulation.
Okay.
And that is, of course, clearly a factor. It's not just overpopulation, it's that the rest of the world wants to be like the US. You know, we use energy at 4 times the rate that even the Chinese citizens use, and 10 times the rate that an African uses. And so as the world advances its standard of living, it needs more energy. Plus, we're getting more people. So yeah, that's a real problem on Earth is how many people will we have and how much energy per capita will they need? And so that's outstripping in many ways our new ideas on new generation of energy. And of course, that all relates to climate change. So that's a problem.
Well, I think it's a really important dialogue to have. I mean, you go on the ship and you go to China and you go to India, where you can see that the atmosphere is affected by the type of energy that's burned or used or whatever. But then you also have to think about, as you said, we consume 4 times as much as the rest of the world, and we're affecting, even if we don't see it in the air, we are definitely affecting it as we live our lives and how we consume product.
Right. And of course, and as I try to point out in that presentation, the striking thing to me is that 20,000 years from now, I think we're going to have a real problem of a cold period on Earth and the glaciers moving back toward the equator. And what will we do with our large population then? Now, maybe what we're doing is going to forestall and kick us out of that cycle, but I doubt it. So.
Well, thank you, Lee. It was wonderful to spend time with you. You're always an inspiration and a whole lot of fun. And so I'm glad we've had this evening together. I'd also like to say happy birthday to Captain Costas for any of you who are listening who sailed with Captain Costas. He's a fantastic guy and it was his birthday yesterday. So happy birthday, Costas. So thank you to everyone for joining us. And we always appreciate hearing about how our alumni are doing. I make buddy calls to the parents of students, and I make calls to lifelong learners potential and past. So it's always wonderful. Semester at Sea is a community of friends and family, and we all want to help them and support them. They are a 501c3, and they really need our help right now. Particularly gifts that are given monthly would be of great help, and gifts of any size. So consider helping the program and during this difficult time so that we can continue to sail successfully. Also, I'd like to highlight that the upcoming Wavelengths, September 30th will be an update from CEO Scott Marshall. October 7th will be a Q&A with Scott Marshall and Audra Brickner. And October 14th, I'm terrifically excited to welcome Dr. Keisho Scott. And her topic will be, how does Semester at Sea prepare students for understanding this Black Lives Matter moment? And I spoke to her in person, and I think she's going to bring her own unique perspective on this, and it will be an engaging dialogue and how Semester at Sea can move forward and be more sensitive to this topic as it continues on. And we also encourage you or anyone else to get the word out there and get Semester at Sea news spread to your friends and family. And also, if you know of anybody who has any special talents who has sailed with us, please email wavelengths@semesteratsea.org if they would like to be considered for a future Wavelength series. So thanks, Lee. It was great to be with you. Yay for Spring 10, but yay to all the other voyages we've all participated in. It's a fabulous, life-changing experience for all of us.
Yeah, it's great to see you, Shelley, again. The last time you were in Knoxville, I think I taught you how to get up on a slalom ski.
It was a highlight of my life. I'd never gotten up on one ski, and cutting in and out of the wake was really awesome. So thanks for sharing that talent with me. So,
yep, you did great.
So good night to all of you, and come back and sail on the ship again. I know I will as soon as I can. Thank you.
Bye-bye.
Bye.